Namaste everyone. Hope all of you are well. Today, I, Sonu Kumar sir, chemistry teacher, going to teach you class 10, chapter number 4, carbon and its compound chapter. Before starting the chapter, I would like to ask you some questions like, do you know these books and notebooks? Means I talk about paper. This paper are made up of what? Made up of trees, right? You know very well. But have you ever thought what is carbon? When the word carbon comes, only one thing knock or stuck at our mind that carbon means coal. Except coal, nothing comes in our mind. But my dear students, carbon is the most important element in the world by which the visibility of the earth, whatever the things you see, is all the things are made up of carbon. Either you see a plastic, these are the chains of carbon, monomers, polymers. Means if I talk about this dress, blazer, shirt, pant, tie, each and everything is made up of this carbons. So without carbon, it's impossible to think nowadays. Second thing, the most important thing which I want to say to you is, what is the percentage of carbon present in the earth crust and in the atmosphere? It's very minimum percentage. 0.02 in the earth crust and 0.03 in the atmosphere. So you can understand about the real carbon. What is the percentage of real carbon? Whenever we start any chapter, as I always say to my students, whenever we are starting any chapter, we should have the biodata of that chapter. If I talk about the carbon, means carbon and its compound, our chapter name is carbon and its compounds, right? This is our chapter name. I have informed you about the biodata of carbon. First of all, carbon, it is an element, okay? So symbol of the element, carbon is C, capital C. What is the atomic number? Atomic number of carbon is 6. What is atomic mass of carbon? Atomic mass of carbon is 12. What is electronic configuration of carbon? Electronic configuration of carbon, in the first orbit it has 2 electrons and in the second orbit it has 4 electrons. When you will go in the 11th standard, that time you will write this electronic configuration as 1s2, 2s2 and 2p2. Means in the first orbit 2 electrons and in the second orbit 4 electrons, which are accommodated as 2 in the s orbital and 2 in the p orbital. This is the electronic configuration of carbon. After that, if I talk about the carbon occurrence, in which form carbon occur in the natures, so especially I talk about the isotopes of carbon. Isotopes of carbon is C12, C13 and C14. Found in earth crust, (0.02%) and found in atmosphere, 0.03%. Allotropes of carbon, diamond and graphite. See, first of all, why I have written this thing? As already I have informed you that before starting any chapter, we must know the biodata of that chapter, the things which we are going to study in this chapter is just like we are going to study about the bonds between the carbon. Which type of bonds do carbon form? How many types of bonds are there? After that, we are going to study the nomenclature of this carbon and its compound. What are the words root of the carbon? What are the linkages of the carbon? Alkane, alkene, alkyne. After understanding the concept of this IUPAC nomenclature, then we will move towards some of the compounds of carbon, how these compounds are formed, and what are the uses of that compounds. So let's begin this chapter with this biodata of carbon. I hope all of you have seen this biodata of the carbon and its compound. As you can see here, so first of all, where this carbon are present, especially this carbon are present in all over the globe in each and every substance. But if I talk about then specific, it is especially petroleum products and it is especially found in the minerals. So this is the main biodata. Now I will talk about the bonds between the carbon. Which type of bonds do carbon show? Bonds. Before making the concept clear of bonds, I would like to ask you and inform you both that do you know about the bonds? What is chemical bond? Can anybody see me? If you know what is chemical bond, just pause the video for a second and write the define of chemical bonding. Now, I am saying you what is chemical bonding. Chemical bonding is the force of attraction between two elements. Force of attraction between two elements means when one element and another element has some requirement of electrons. Why they will have requirement of electrons? Because to complete their octet in the last cell. If they have requirement of electrons or they want to lose the electrons, for that purpose, if two elements chemically they bind a force, they arise a force, and that force of attraction is called chemical bonding. The force of attraction between the two elements is called chemical bond. There are totally 6 types of chemical bonding. First, ionic bond. Second, covalent bond. Third, that is the most important, coordinate bond. Fourth, metallic bond. Fifth, hydrogen bond. And sixth, van der Waals bond. So there are total 6 types of chemical bonding, in which I will just describe you especially about the two, ionic bond and covalent. How ionic bond is formed? Ionic bond is formed by transferring or gaining of electrons. If I talk about sodium chloride, in the sodium chloride what happens? Sodium transfer one electrons to chlorine and chlorine gains one electron from the sodium. So by this transferring and gaining, a bond is formed. That bond is called a chemical bond. And in our whole carbon and its compound, we are going to study about covalent bond. Which one? Covalent bond. What is the meaning of this covalent bond? Covalent bond means I am talking you this valency. Co means outside cell, means outer cell. Whatever the number of electrons are there, it will do sharing of electrons. If I talk about carbon, you can see I have written the electronic configuration 2 and 4. In the first cell, carbon has 2 electrons, and in the second cell, carbon has total 4 electrons. How many electrons? total 4 electrons in the last cell. So outer cell you can see the carbon has total 4 valence electrons. 1, 2, 3, 4. Just suppose these are the 4 electrons of outer cell of carbon. So now carbon can't donate these 4 electrons. If it is removing this 4 electron, then it will get 1s2, that is the helium configuration, noble gas configuration. But the carbon has a tendency to accept 4 electrons. Means if I talk about a hydrogen atom, just suppose hydrogen is having 1 valence electron. There are total 4 hydrogen atoms. You can see here the 4 hydrogen atoms. These are hydrogen atoms. Now, this carbon has a tendency to accept 1 electrons from this hydrogen. Means total you can see here the carbon has taken how many? Total 1 electron it has taken from hydrogen, from this hydrogen, from this hydrogen and from this hydrogen. So total 4 valence electron it has taken. Now hydrogen has not completely transferred. Hydrogen has said that, dear sir, if I want my electron, then if you want my electron, then you have to share your electrons. Why you have to share? Because if you share 1 electron with me, then I will get doublet and I will complete helium configuration. So here carbon share its 4 electrons with the respective all the 4 hydrogen atoms, and the hydrogen atom completes it duet and carbon atoms complete its octet. So you can see by sharing of electron, when 2 elements, any elements, M, Lu elements, X, just suppose these are the 2 elements, just I have written any element symbol, you can take any elements. It just suppose that oxygen atom, leave this annex. So if I talk about oxygen, can you tell me how many valence electrons are present in the oxygen atoms? Oxygen atomic number is 8. In the first cell it has 2 electrons and in the second cell it has 6 electrons. So in the second cell the oxygen is having 6 electrons. 1, 2, 3, 4, 5, 6. This cross symbol I have represented with the electrons. Now you can see what will happen. If this oxygen will take these 2 electrons from this oxygen, so this oxygen will get 8 electrons. Similarly, if this oxygen will also take these 2 electrons from this oxygen, then this oxygen also octet complete. So they can't completely transfer, they can share their both the electrons with each other, and the bond forms by the sharing of electrons is called covalent bond. So if anybody will ask you what is covalent bond, that time you can see the bond which is formed by the sharing of electrons is called covalent bond. The bond which is formed by the sharing of electrons. Why they do the sharing of electrons? Because to complete their octet or duet in their outermost cell. What is this octet and duet? This octet and duet means nearest inert gas configuration. Nearest inert gas configuration means hydrogen will attain helium configuration, carbon will attain neon configuration. So when they complete their duet or octet, means they are completing their nearest inert gas configuration. So as we have seen, the bonding between the carbon we have to study is the covalent bond. Now, after understanding these things, now can you tell me that can carbon lose these 4 electrons and carbon can gain the 4 electrons? You know very well. But if I talk about if carbon lose the 4 electrons, then what will happen? If carbon lose 4 electrons, then carbon will form C4 plus cation. It would require a large amount of energy to remove 4 electrons, leaving behind a carbon cation with 6 protons in its nucleus holding on just 2 electrons. Remember, dear students, if I talk about all the 4 electrons, then carbon will form C4 plus. But to remove one electron from an isolated gaseous atom is called ionization potential. IP. Have you heard IP? You may have seen this IP in many things. You can see this thing especially in the medicines, in cosmetic things, in toothpaste, and everywhere you will see this IP. What is this IP? IP means ionization potential. The minimum energy required to remove one electron from an isolated gaseous atom is called ionization potential. So if you want to remove one electron, that time the amount of energy you will require. But here in the case of C4 plus, you will require much more amount of energy because you are removing this electron, and that time it will have only 2 proton, and you have removed, sorry, it will have 6 proton and 2 electrons in the outermost shell. So it will be very difficult, it will not gain stability. So that's why generally carbon accept 4 electrons. If it is accepting, it will be known as carbon anion, C4 minus, and this is carbon cation, C4 plus. So dear students, carbon has a property of covalent bond. Which one? Covalent bond. After that, if I talk about that, this by sharing its valence electron with the other atom, do carbon form cation or anion? My dear student, first of all, not just carbon but many other elements form molecule by sharing electrons in this manner. The shared electrons belongs to the outer shell of both the atom and lead to both the atoms attaining the noble gas configuration. If I talk about any element means any element. Just suppose that hydrogen, oxygen, carbon, nitrogen, any other atoms, if they want to complete their octet, first thing comes why they should share with their own type of element. Means if I talk about nitrogen, then nitrogen will share its electron with nitrogen. To give N2 means in the form of molecules. This molecule word. Remember the word molecule. Why? Because here you know very well nitrogen has 5 valence electron in its outermost shell. Right? 5 valence electron in its outermost shell. So you can see this 5, this will share with this electron, this electron, this electron. So this nitrogen has completed its octet. Similarly, this nitrogen has completed its octet. So you can see what happens when they form a molecule. That time there is no bonding of sharing an electron. So here you can see that nitrogen has formed. Similarly, oxygen also, I have shown you also 1, 2, 3, 4, 5, 6, and second oxygen also 1, 2, 3, 4, 5, 6. So here this oxygen will share these 2 electrons with this oxygen. Similarly, this oxygen will share these 2 electrons with this oxygen. Oxygen will also form as the O2 molecules. Hydrogen has 1 valence electron in its outermost shell. So they both will share 1 electrons with each other and they will complete duet helium configuration. So this can be also formed as the H2O2 N2. So these are the things which you should know, that why do they do the sharing? They do sharing to gain nearest inert gas configuration. Nearest inert gas configuration. Now anybody will ask you, what is this nearest inert gas configuration? My dear student, all the noble elements means helium, neon, argon, krypton, xenon and radon. These are inert gas elements and their general electronic configuration is Ns2np6. This is 1s2, this is 2p6, 3p6, 4p6, 5p6, 6p6, and an octium has 7p6. So this is noble gas configuration. Means each and every element has tendency to gain this configuration because this configuration are stable. What are this configuration? Stable. As we have seen that what the things I have discussed, this was the biodata of carbon, the bonds of carbon, which type of bonds carbon form and why do they form. Now the main important thing of this chapter that we are going to study is the allotropes of carbon. Have you heard the word allotropes? Allotropes, the graphite and diamond. If you have seen the GSCP book, Gujarat Secondary Examination Board books, in that the first chapter is Science and Nanotechnology. Buckyball. Means this graphite and diamond are made up of carbon only. When you will draw the structures, and you can see the structures also in the NCERT, that how the structures are formed of this diamond and graphite. They are having sp2 hybridization, means they are sharing their electrons in the sp2 form. The allotrope, generally you have to remember the diamond and graphite, and if you want to draw the structure, is already present in NCERT. Let's start solving NCERT in-text problem. So first question of in-text problem is that what would be the electronic dot structure of carbon dioxide which has the formula CO2. Now you can see carbon dioxide, CO2. You have to represent dot formula. Dot formula means sharing of electron covalent. Carbon has total 4 valence electron. Oxygen has total 6 valence electron. How many valence electron? 6 valence electron. So what you will see here? You will see that carbon will share this 1 electrons with the oxygen atoms, both the oxygen atoms, and carbon will get its octet 1 2 3 4 5 6 7 8. You can see carbon had got its octet. Similarly, this oxygen will also share this 2 electrons from the carbon, and this oxygen will also get 2 electrons from this oxygen. And now you can see all the 3 elements have completed their octet. Means carbon also have got 8 electrons, oxygen also 8 electrons, and this oxygen also 8. So by this way you can represent the electronic dot structure of carbon dioxide. What would be the electronic dot structure of a molecule of sulfur which is made up of S8 atoms? S8 atoms. The 8 atoms of sulfur are joined together in the form of a ring. My dear student, I am showing you how these sulfur atoms are formed. Total sulfur has 6 valence electrons. You know very well, 1 2 3 4 5 6. All the sulfur atoms have 6 valence electrons. S8 atoms, 3 3 6 2 8 rare. See, have you ever seen, just I am showing you, have you ever seen a reliable chair? How its structure is that? First let me show you. Aram kursi, you know Aram kursi? You may have seen that chair. Wait, let me make this chair first clear. See, this is the chair. Here we keep our head, and when we keep our both the legs on this chair. So this is the reliable chair. Here what do this? You can see here 1, 2, 3, 4. This fifth and sixth electrons are sharing their electrons. 1, 2, 3, 4, 5, 6. Here also you can see 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. See, all the sulfur has completed its octet. You have to draw this reliable chair very easily from it, as I have just drawn and shown that all the sulfur atoms are sharing their 1 electrons with 2 sulfur atoms and completing its octet. If you want to draw very nicely this format, then I am showing you. First of all, draw one sulfur here and represent their 6 electrons. 1, 2, 3, 4, 5, 6. Okay. Now this sulfur atoms here, one sulfur, 1 electrons is this by shared with 1 electrons, and this another is with this sulfur atom here. Similarly, this sulfur atom has shared another electrons with this sulfur atom. So you can see 1, 2, 3, 4, 5, 6, 1, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now here again this sulfur atom and this sulfur atom. So 1, 2, 3, 4, 5 and 6. This sulfur atom with this sulfur atom. 1, 2, 3, 4, 5 and the 6. Here this again it will form, you can see here. Here it will go down and here this will become straight. So here you can see this sulfur atom also 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So here this sulfur atom will again share 1 electrons with this, and you can see all the sulfur atom has completed its octet. So there are total 2 to 4 to 6, 8 S8 atom. This is sulfur 8 S8. It is in the form of chair, reliable chair. So this is our in-text question. You can see, and you can make, here it is written that you can form a ring structure, are joined together in the form of ring structure. So you can make a ring also if you want to form all the sulfur atom, S8 atom in the ring. 1, 2, 3, 4, 5, 6, 7, 8. You can see all that. This will be in the ring form. But generally, if you ask me, this is the right structure of S8. When you will go in the higher standard, that time you have to learn these things only. Okay. So now the main thing of this index question was that you should know the valence electron of the atoms. How many valence electrons are present in the different elements, and how do they do sharing with the other elements to complete its octet. Hope you understand about this completing the octet of other elements. Now the versatile nature of carbon. Carbon has a unique tendency, Carbon has a unique tendency to attain the stability. Why I am saying you this unique tendency? Because the formation of covalent bond by the sharing of electrons in the various elements in compound, you may have seen the structure of simple carbon compounds. Means now we are going to specially discuss about the main things of carbon, that is versatile nature, saturated and unsaturated. Saturated and unsaturated means, what is this saturated and unsaturated? Saturated and unsaturated means because now we will move towards the bonding of carbon. How carbon forms the bonds between their self atoms. Means now the bonds, before going towards the bonds, you should know about the 3 things, that is Wurtz root. Wurtz root means number of carbons. Counting, as you know, 1, 2, 3, 4, the counting. Similarly, now we'll discuss about the counting of carbons. Counting of carbon means what is the number of carbons, what will say to the words root, what will say to the linkage of carbons. Okay, so now first of all, words root. Bonds means it is also known as linkage. Okay, there are total 3 bonds between carbon-carbon atoms. Single bond, double bond and triple bond. Remember dear student, this is carbon has total 4 bonds, so you should remember that whenever carbon will be connected, it will have total 4 bonds. Because 4 valency, you can see the valency of carbon is 4. Now, as I have told you, the single bond, double bond, triple bond, it is also known as alkane, alkene and alkyne. Okay, before moving towards these 3 things, I would like to tell you the counting of carbon, that is called words root. Words root means number of carbon. C1 to C10 we will learn. C1, C2, C3, C4, C5, C6, C7, C8, C9 and C10. It is known as meth, M-E-T-H, meth. C1 is known as meth, C2 is known as eth, C3 is known as pro, C4 is known as bute, C5 is known as pent, C6 is known as hex, C7 is known as hept, C8 is known as oct, C9 is known as non, C10 is known as dec. You can go ahead also, undec, dodec, C11, C12, you can learn like this. Just when primary student learn 1, 2, 3, 4, they learn 1, 2, 3, 4. Now you are senior students. Now you are learning the 1, 2 of carbons, number of carbons. Here there is 1 atom of carbon, you can learn as a meth, 2, eth, 3, pro, 4, bute, 5, pen, 6, hex, 7, hep, 8, oct, 9, non, 10, dec. Now, single carbon, how many valency of carbon is there? There are total 4 valency of carbon. So you know very well, here single carbon will have total 4 single bonds. So single bonds is known as alkane. So how many carbon is there? 1 carbon is there, C1, and the single bonds will be formed by the hydrogen, you know very well, right? Single bonds will be formed by the hydrogen. So how many hydrogen will be there? 4 hydrogen. C1H4, right? Or CH4. Single bond we have to represent A and E. Meth plus A and E called methane. This CH4 will be known as methane. What it will be known as? Methane. Similarly, there are 2 carbons which will have single bonds. All the carbon will have how many valence electrons? 4, means valency will be 4. So 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. You can see both the carbon is having 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. Now keep hydrogen. 1, 2, 3, 4, 5, 6. How many hydrogen? 6. So C2H6. What will be the name of this compound? Eth plus A and E. Ethane. What will be the name of this compound? Ethane. Means if we try to calculate all these carbon atoms single bond, C1 to C10, you will see that here the number of carbon twice plus 2 hydrogen means CnH2n plus 2. If carbon is 1, if the value of n is 1, So C1H2 into 1 plus 2. 2 ones are 2 plus 2, 4. So C1H4. If we put C2, 2 2s are 4 plus 2. C2H6, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. Can you write this chemical formula and structure? Your today's homework of this video is you have to write from methane to decane. All the names means first of all you have to write the words root. Meth plus A and E, methane, chemical formula CH4, structural formula, you have to draw this structure. So from C1 to C10 means methane to decane, you have to write chemical formula and structural formula in your notebook. Before ending this video, I would like to inform you, in the next video, we will learn the nomenclature of carbon, IUPAC name of carbon. This is the initiative of this IUPAC name, but in the next video, we will discuss about the IUPAC nomenclature of carbon from alkane to alkyne, acetylene, ethene, many things we will learn. So I hope the introduction of this carbon and its compound you may have understand. If you have not understand, then drop your doubt into the comment box section. So as I will make the next lecture, lecture number 2, in that video I will solve your doubt. That's all for today. Thank you very much. If you have not liked and subscribed my channel, then don't forget to like and subscribe. Share this video with your friends so they can be also benefited. Thank you very much.